Okay, so the next thing that we have here is the relationship between the basically the zeros of a third degree or cubic polynomial and the coefficients, meaning that if you have basically you have a third degree polynomial would be, for example, something like p of x is equal to ax cubed plus bx squared plus cx plus d. This is a cubic polynomial. Basically, the degree here is 3. Here the degree is 3, and then you can take the roots as alpha, beta, and gamma, for example. Okay, so you have basically at most we already talked about this. You can have at most 3 roots over here. Now you can basically write this in the form of the factors that it could have. So the factors would be, for example, x minus alpha times x minus beta times x minus gamma. If basically alpha, beta, and gamma being the zeros, of p of x. Okay, so then your p of x is basically written in a factorized form, and there is a couple, I don't really remember where or how, but there is a theorem using which probably we will get to that theorem. I don't really know, but there is a theorem that where you can actually prove that every for example, every first degree polynomial ax plus b. Of course, here you don't need to factorize anything. So here your basically your 0 is basically, if you set this equal to 0, then your x is equal to minus b by a. So there is no need to do all of this business of factorization there. But any second degree polynomial like ax squared plus bx plus c, if you set that equal to 0, there is a theorem that states that any second degree polynomial can be written in terms of in a factorized form, and the factorized form would be x minus, for example, x1 being one of the zeros, times x minus x2 is equal to 0, and then you can, based on that you can say that you can find x1, and here x is equal to x1, and here x is equal to x2, for example. Okay, and also for any third degree polynomial ax cubed plus bx squared plus cx plus d, this is a cubic polynomial. You can basically there is a theorem that states that it can be written in terms of the zeros, meaning that you can write it as x minus x1 times x minus x2 times x minus x3, and then basically here your zeros would be x is equal to x1, here your x is equal to x2, and here x is equal to x3. Okay, so now based on that, I'm writing these relationships. And now I have actually factorized this polynomial as x minus alpha, beta, and x minus gamma, alpha, beta, and gamma being the zeros of p of x, the polynomial itself. So now if you actually multiply, for example, multiply these two first, you would get x squared minus beta x minus alpha x plus alpha beta, and then that is times x minus gamma. Okay, and then if you multiply this as well, you'll get x cubed. You'll get x cubed minus bx times x is equal to, minus beta x squared minus alpha x times x is equal to minus alpha x squared, and alpha beta times x is equal to plus alpha beta x. And then if the same thing times negative gamma, you would get negative gamma x squared positive beta gamma x positive alpha gamma x and negative alpha beta gamma. Okay, and then you can write this as x cubed, and this is x squared. So that is negative beta x squared, negative alpha x squared, negative gamma x squared. I take a negative x squared out, and I write this as alpha plus beta plus gamma. Okay, and then I erase these things and go for the x terms. So here I have an x, here I have an x, here I have an x. So I take an x out and write this as alpha beta plus beta gamma plus alpha gamma. And then you have this negative alpha beta gamma over here. So what that means is that you have x cubed minus alpha plus beta, minus alpha plus beta plus gamma times x squared, and then you have plus alpha beta plus beta gamma plus alpha gamma times x minus alpha beta gamma. So then you have actually written your basically you have ax cubed plus bx squared plus cx plus d, and you can see that now in factorized form, basically this corresponds to basically negative of alpha plus beta plus gamma corresponds to b, and c corresponds to this whole thing over here, and d corresponds to negative alpha beta gamma. So now usually what you're looking for is the sum of the zeros and the product of the zeros. So then you can figure that out based on what you have here. So you have sum of the zeros alpha plus beta plus gamma. You can find it over here. So that's actually that is b, and because this is a, b, c, and d, so that is b here, and you can divide that by a. So your a is 1, so that is b by a, but there is a negative sign here. So if you multiply a negative by this by b, which is inherently negative, then becomes positive, and then you get a positive alpha plus beta plus gamma here. So that is one thing, and then the product of the zeros is alpha beta gamma. So alpha beta gamma is is this thing over here, so you can write it as, so this is C basically, so you can write it as C by A, and then you need to add a negative over here as well, because this is inherently negative and I have written it as a positive term. And then there is also this thing over here that you can probably use it sometimes, I don't know. It's the product of the, it's kind of a cyclic product of the three zeros, meaning alpha, beta, and gamma. So alpha times beta, and then beta times gamma, and then alpha times gamma. This way you can actually somehow learn this. So first alpha plus beta, then beta times gamma, and then alpha times gamma. So it's alpha beta plus beta gamma plus alpha gamma is equal to actually ABC, C divided by A is equal to C divided by A. So that's basically the three relationships that you can find between the zeros of a cubic polynomial and the coefficients of the coefficients that you can find in the same polynomial. And let us do a couple of examples in order to work with this a little bit. So for example, let's say that you have something over here. Let's say that you have a cubic polynomial, for example, p of x is equal to 3x cubed minus 5x squared minus 11x minus 3, okay, and you want to verify the relationship to zeros on the coefficients. Now first of all, so let's find the zeros of this polynomial first, and then we will verify the relationship between the zeros and the coefficients of this polynomial, okay? So in order to find the zeros of this polynomial, what you need to do is let me see. Okay, so now in order to solve this polynomial, basically it's specifically this one is a little bit tricky, because usually, for example, sometimes what you can do is that, for example, take these two polynomials together, these two ones, for example, and these two together, something like that, and then for example write this as take an x squared out, and then here you have 3x minus 5, okay, and then take this as, so minus 11x minus 3, or 11x plus 3. So you see this doesn't work. If you had, for example, some example like let's say you had, for example, something like 4x cubed minus 20x squared plus 7x minus 35. Let's say you had this polynomial and you wanted to find the zeros of this polynomial. You could take these two together and take these two together, and then from these two you can take your 4x squared out, and then you would end up with x minus 5, right? And then from these two you could take a 7 out, and then that would be 7 minus 5, and then you could take the x minus 5 out, and then that would be 4x squared plus 7, and then you would have this first degree polynomial times the second degree polynomial, and then you would have to basically find some way to solve this second polynomial by, for example, writing it as so 4x squared plus 7, you can write it as 2x whole squared plus, for example, square root of 7 whole squared, and then you would write this as, this is a squared plus b, or that is plus, right? So you could actually, what you could do, you could make some changes to this. You see how you have 4x squared plus 7, so you can write it as, you could write it as 4x squared minus 7. That would be the same thing. And then you could write it as, you could write this as 2x whole squared minus so if I write, for example, this as if I write this as I couldn't do that. I couldn't, for example, I couldn't write this as the square root of negative 7 whole squared. That's basically not possible, because I cannot take the square root of a negative number. That's basically not possible. So but basically you could do something like this over here and somehow get a first degree polynomial and a second degree polynomial and solve the problem that way. But about this one, it's a little bit tricky, and for this particular one you would need to use something called synthetic division. And in synthetic division there is a technique that you use in order to basically break this polynomial down into a second degree polynomial times a first degree polynomial, and then solve it that way. We will get to basically that sort of thing later in later videos related to polynomials, but not here. Now the best way for now to figure out what the roots or the zeros here are is simply, right now sometimes you basically need to cheat, and the best way to do that is to draw the graph of the polynomial, and then wherever the graph of the polynomial goes through the x-axis, that's basically the zeros of your polynomial. So you write it as, for example, 3x cubed minus 5x squared minus 5x squared minus 11x minus 3, and you see that your polynomial goes through the x-axis at these points. You see, this is x is equal to 3, this is x is equal to half, and this is x is equal to somewhere about, I don't know really. So this point is negative 0.333, so this is 1/3, I suppose. So this is 1/3, negative 1/3, this is negative 1, and this is positive 3. And you know that basically 1/3 is equal to 0.3333, and so on and so forth. So now I know that my roots, my zeros are negative 1. I know that my root, and you don't have to worry about the fact that we didn't solve this polynomial. We will get to that in the next videos that we have about polynomials. I don't know when we are going to do that, but it's not going to be, it's going to be, I mean, it's going to be pretty soon. So your basically x1 is equal to -1, x2 is equal to -1/3, and x3 is equal to +3. Okay, so I call this alpha, for example, beta, and gamma. So that's basically that. Now, in the previous, basically over here, we said that there is these relationships between the roots and the coefficients of a third degree polynomial. So over here, so for example, if you calculate the sum of these roots, you will have alpha plus beta plus gamma is equal to -1 plus -1/3 plus 3, which is equal to 3 minus 1 is equal to 2. 2 minus 1/3 is equal to so there you have 2/3, so 1 and 1/3. It's 1 and 1/3, which is equal to 4/3, I suppose, if I'm not wrong. So 2 minus 1/3 is equal to 3, and 6 minus 1 is equal to 5/3. 6 minus 1 is equal to 5/3. Oh, this would be actually 1 and 2/3, right? 1 and 2/3. So 1 and 2/3 is actually 5/3. That's right. That's right. Okay. So that's 1 and 2/3, which is equal to 5/3. So then your alpha plus beta plus gamma is equal to 5/3, right? Now, over here in the polynomial, if you calculate minus b by a, what you will get is that basically that's negative minus of -5 over a, which is equal to 3 here, which is equal to 5/3. So you see 5/3 over here, 5/3 over here, so that means that alpha plus beta plus gamma is equal to minus -b by a. And then if you calculate the product of the zeros here, alpha, beta, gamma, that's equal to -1 times -1/3 times 3 is equal to -1 times -1/3 times 3. That's equal to +1. That's equal to +1. And that's supposed to be equal to -c by a. Now -c by a is equal to here. And that's -c by a is -11/3. A, B, C. That's positive 1/3 times 3 is equal to +1. Now alpha, beta, gamma is equal to -c by a. -c by a is equal to, this is A, B, C. Oh, there might be something wrong in here. 3x cubed minus 5x squared minus 11x minus 3. that's negative c by a would be minus of negative 11 by 3, which is equal to 11/3. Okay, that doesn't work for whatever reason. And let's see what happens if I calculate alpha beta plus beta gamma plus gamma plus alpha gamma. Okay, so alpha beta plus beta gamma plus alpha gamma is equal to these three roots basically over here. So alpha beta would be -1 times -1/3 times -1/3 plus beta gamma would be these two multiplied together, so -1/3 times 3, and then alpha gamma would be -1 times 3. -1 times 3, so that is that's positive 1/3, and that's -1, and that's -3. So that's 1/3 minus 4, which is equal to 5 and 2/3, -5 and 2/3, which is equal to -17/3. Let me make sure I haven't made any mistakes here. So 1/3 minus 4 is equal to 1 minus 12, right? No, this is wrong. I'm sorry. This is wrong. This is 4 minus 1/3 is equal to 3 and 2/3, so minus 3 and 2/3, which is equal to 9 minus 11/3. So that's equal to -12 plus 1 is equal to -11/3, which is right. Okay. So that's equal to -11/3. Now, if you calculate here c by a is equal to -11/3. So c by a is equal to -11/3, and you can see that alpha beta plus beta gamma plus alpha gamma is equal to c by a. But the only thing that here doesn't work is the second one, which is the product of the roots. So let's see what the problem here is. So you have alpha, beta, and gamma is -1, -1/3, and +3. So that's a positive, that's supposed to be a +1. 3/3 is equal to 1, so that's a -1, -1 times -1 is equal to +1. And negative c by a is 11/3. I do not know why it doesn't work. Let me see. Well, it doesn't work because I have written this wrong. This is actually supposed to be -d by a, I suppose. Alpha, beta, gamma is -d by a and not -c by a. So that's why it doesn't work. So -d by a here is negative of -3 by 3. So over here I need to make some changes. So -d by a is equal to, over here is equal to negative of -3 by 3, which is equal to a 1. So that means that alpha, beta, gamma is equal to is equal to negative d by a. Okay, so that's basically that. Now, about solving these kinds of problems, about factorizing this kind of polynomial, about that we will talk about that later in later videos. And we have a couple of examples that we will do in the next video. I'll see you in the next video.